Good day, everyone. You are welcome back to our channel. In the last video, we looked at question 7 of May-June Met Paper 1 of 2024. In this current video, we will be giving solutions to question 8. All right, let's get to it. All right, you're welcome. In this video, we'll be looking at solutions to question 8. The first question, 8.1, says determine f prime of x, the first derivative of f of x, from the first principle, if f of x equals 1 over x. Now, what I always advise my learners to do here is that you can use the simple method to calculate f of x, and that will serve as a guide to confirm if the derivation from the first principle you do is correct, right? So if you differentiate f of x equals 1 over x, the differentiation using the simple method is very simple. All you need to do there is to turn 1 over x into x exponent -1. Right? And I believe you know what is happening there. So 1 over x equals x exponent -1. Now, if you differentiate x exponent -1, you will have if you differentiate x exponent -1, you will obtain negative x exponent -2. And that can serve as a guide for you, and it will help you confirm if what you have derived from the first principle is right. If you don't have the same answer at the end of derivation from the first principle compared to what you got in the simple method, then you have to look at your first principle again to ensure that you have not missed anything out. All right, so let's derive from the first principle. From the first principle, you have to simplify this. You have to turn 1 over x to x exponent -1. And I believe you still remember the law of indices. So that is what we apply there. Then you go to your formula paper and you write out this formula. So this formula is what you use to determine or to derive or to get the first derivative from the first principle. So this thing is not properly written here. So you can see, I will write it. You can see the correct version on the board. So it's lim h tends to 0. Then you have f of x plus h minus f of x over h. Intentionally, I put this in square bracket. I put this f of x in square bracket for a reason. And the reason is that sometimes you are dealing with a function that has negative sign in front of the terms. So if you have negative sign in front of the terms, you cannot simply put everything directly into this. There will be an error there. So it's important you put this f of x in bracket, and you must take note of this minus. So this minus affects every term in f of x. Next, we will just make appropriate substitution. And when you are deriving from the first principle, this lim h tends to 0 must be there till the final step when you substitute h equal to 0. If you omit this lim h tends to 0 at any point during your calculation, an examiner that is not happy when he's marking can penalize you. So you just have to make sure that you put this lim h tends to 0. So we'll be putting it. I've already told you and I've shown you the correct way to put this lim h tends to 0. So here we have f of x plus h minus f of x over h. So what this simply means What f of x plus h means is that anywhere you find x in the original function, you must replace that x with x plus h. That is what we have here. Then remember, you have -1 here as exponent. Then minus f of x. F of x itself is x exponent -1, right? So we get here. Now let's look at the numerator. The numerator is x plus h, everything exponent -1, minus x exponent -1. So that x plus h, everything exponent -1, can be rewritten as 1 over x plus h. We are dealing with the numerator now. Then minus, we can now rewrite x exponent -1 as 1 over x. Then everything divided by h. And we can simplify this. So if you simplify that, if you look at the numerator, we can find the LCD, the lowest common denominator there. And that will be x plus h multiplied by x. And if you solve that, you will have this x minus h. Here, x cancels out minus x. You are left with negative h on top. Then if you look at it, we have negative h over x plus h multiplied by x, then divided by this h. H is the same as h over 1, right? So we switch that division sign into multiplication. So once we do that, 1 goes up and h comes down when you have this multiplication sign there. So here you can see h cancels h. In the numerator here, you have -1 times 1, which is -1. Then you have the numerator down. You have the denominator below. So here you can see that you will have -1. At this point, you can then substitute h tends to 0. You can substitute 0 wherever you find h. So we have h here. If you put 0 here, it means that this equation, this denominator will be x times x, which is what you're having here. So you have -1 over x times x. We can drill down. X times x is s squared, right? So we have -1, right, divided by s squared. So you can simplify this. You can leave your answer this way, or you can simplify it to -x exponent negative. So you have -x exponent -2. So if you compare that to what we used in the simpler method, you will see that these two values are the same. The two answers are the same. That serves as a confirmation that our derivation from the first principle was correct. The next question is question 8.2. We have two sub-questions there. 8.21 says we should determine this. dd of x, then the square root of 4x to the power of 6 plus the square root of 2 multiplied by s squared. Normally, to solve this kind of a question, you will have to simplify the expression. You simplify the expression. So let's see how the simplification works out. So here, we can remove the square roots. And when we remove the square root, we will have 4x exponent 6. Then everything will be to the exponent of half plus root 2 multiplied by s squared. We can simplify that further. We can turn that 4 into its exponent form. So that will be 2 raised to power 2, x to the power of 6, then the square root, which is exponent r, multiplied by this. So if we solve this r affects all the exponents in this bracket. So for these two, we have 2 exponent 2 times r. So 2 cancels 2. You are left with 2 exponent 1, which is 2. Then you have x exponent 6 times r. Have 2 in 6 is 3. So that is the reason for this x exponent 3, then plus the square root of 2 multiplied by s squared. So at this point, we can differentiate. So to differentiate here, this will be 3 multiplied by 2. That gives us 6. Then x exponent 3 minus 1. So that will give us exponent 2 here. Then this will be 2, the exponent here multiplied by root 2. That will give us 2 root 2, then multiplied by exponent x. So if we simplify this further, we can take these 2 into this bracket. That turns to 4, then multiply by x. So eventually we have 6x squared plus root 8 multiplied by x. And that solves question 8.2.1. Let's solve question 8.2.2. For question 8.2.2, they want us to solve for the first derivative of g if g of x equals 3x exponent 4 minus 4x exponent 2 plus 6 over s squared. This s squared is a common denominator. It means we can divide each term in the numerator by s squared. So we are splitting the numerator. So here it will be 3x exponent 4 divided by s squared minus 4x squared divided by s squared plus 6 divided by s squared. So we can simplify that. So this simplifies to, if you solve this, it becomes 3s squared. S squared cancels s squared there. You have 4. Then here, this 6 over s squared becomes 6x exponent negative 2. Now we can derive in this form. So the first derivative, g prime of x, would be 2 times 3, that would be 6x. This negative 4 is a constant, so you don't need to derive it to be 0. Then this will be negative 2 times positive 6, that gives negative 12. Then x to the power of negative 2 minus 1. So the exponent here will be negative 3. Question 8.3. The equation of the tangent to f of x equals 3s squared plus bx plus c at x equals 1 is given by y equals 9x minus 9. Is given by y equals 9x minus 9. Determine the values of b and c. So what happens here is that we have to consider that point x. And that point x is the point on the x-axis, is the x-coordinate of the point of contact of the curve of f of x and the linear line 9x minus 9. So that's x-coordinate of 1 is the point of contact. What happens here is that that point x equals 1 is both on function f of x and the linear line 9x minus 9. So what happens now is that if x or if point x equals 1 is on the linear line 9x minus 9, then we can look for the corresponding value of y. We can look for the y coordinate at that point of contact where x equals 1. If we substitute x equals 1 into the linear equation, we would see that y will be equal to 0. So it therefore means that at the point of contact between the linear line, that is at the point of contact between the tangent and the curve of f of x, the s coordinate will be 1 and the y coordinate will be 0. That is what I represent on this diagram here. So you can see here, the s coordinate is 1 and the y coordinate is 0. Now, since that point of contact is also located on F, then we can substitute y equals 0 and x equals 1 into function f of x. So let's see how that works out. So we can calculate y coordinate at x, and we have calculated it by substituting x equals 1 into the equation of the tangent. So that point, that is the point where this tangent meets the curve, the point of intersection also lies on F. So we've stated that already. So now we can substitute this coordinate x equals 1 and y equals 0 into f of x. So if we do that, we know that f of x equals 3s squared plus bx plus c. So here we have y, which is f of x, and we substitute x equals 1 into this. So if we simplify that, it means that 3 plus b plus c will be equal to 0. So that can serve as our equation 1. Now, to determine the equation of the gradient of f of x, we have to differentiate f of x once. That is, we have to find the first differential of f of x. So the first differential of f of x will be 2 times 3. That will be 6. Then x to the power of 2 minus 1. So that will be x to the power of 1. We don't need to write that 1 there. Then we have 1, which is the exponent of x here, multiplied by b. So that simply gives us b, then x to the power of 1 minus 1. That will be x to the power of 0, which is 1. So 1 times b is b. So this equation of the gradient of f of x is very important. Now, when you are dealing with a straight line and a curve, the gradient at the point of contact is always the same, right? The straight line, the linear line we are dealing with here is a tangent. So tangent is a form of a straight line. So at the point of intersection, at the point of contact, the gradient of this line, the gradient of the tangent would be equal to the gradient of the curve at that point. So it means that if the gradient of the straight line, if the gradient of the tangent is 9, as you can see here, this is the equation of the tangent, which is a straight line. You will see that the gradient is 9 here. It means that the gradient of the curve would also be equal to 9. So it means that the gradient of the curve will be equal to 9. And here we have determined the equation of the gradient. So that is the point I'm making here. The gradient of f of x at the point of contact will be the gradient of the linear equation. So it therefore means that we can equate this equation of the gradient of f of x to 9, because the gradient of f of x at this point would be 9. The gradient of this curve at this point is 9. That is, it is equal to the gradient of this tangent. So we have 6x plus b equals 9. We can make b the subject. So b will be equal to 6 minus, b will be equal to 9 minus 6x. Now, we can substitute x equals 1 into this equation. So if we substitute x equals 1 here, since the coordinate at this point is 1, if we substitute that x equals 1 into this equation, we have 9 minus 6 multiplied by 1, which means that b will be equal to 3. Then to calculate c, we can substitute b equals 3 into equation 1. So by so doing, we have 3, this 3 here, plus b, which is 3, plus c equal to 0. If we make c the subject, we will see that c will be equal to -6. So therefore, we can rewrite this f of x. So f of x will be equal to 3x squared plus 3x minus 6. But we are not told to find f of x. We are only told to calculate the value of b and c, which are 3 and -6 respectively. So thanks for staying with us till this moment. We have come to the end of question 8. Next, we'll be looking at solutions to question 9. See you soon.